Okay, hello. So I am going to be giving the third talk today about something that's close to my heart, considering I'm probably one of the only users so far. And it is, it's built really well on the previous two talks as well, which is why I feel like the agenda was so great. And so the agenda of the talk today is pretty much to discuss the Node ecosystem in general, how it's grown over the last few years, and then discuss some of the problems that I think has been coming out of that growth, and hopefully a solution I can convince some of you by, or at least get some of you to think about, and how we can actually solve it and move forward. So the Node.js ecosystem has grown massively. I mean, we have tons of, these are the most popular, or some of the most popular servers, serverless, different technologies that we have nowadays. And as was mentioned to me earlier this morning, we have some that are added almost daily, right? Like even today on Hacker News, it was something that was pretty identical that came out. And if we look at the comparison between these actual technologies, I just wanted to discuss some of the actual focuses that they have. So if you look at, for example, AWS Lambdas that we spoke about earlier, they work great in serverless, which is awesome. If you try and run it in an actual server, probably not so well, right? Can't exactly Dockerize and put in production. The other aspect is functions. So with functions, we say, okay, so is the focus of this actual library and framework the ability for you to write your code in individual pieces, like a modular set? Or is it part of a much bigger ecosystem of having classes and nested dependencies and so forth? I think one of the big things between functions and classes as well is the fact that classes also tend to have a lot of boilerplate, which tend to be things like decorators, injectable tags, and so forth. So things tend to get a bit complicated. The third thing, which is really near and dear to my heart, is services, which is dependency injection. So if you're using something like Nest.js or Loopback or something, you can actually say, okay, I'm running this production code or this code, and I expect to depend on an email service, for example, in a database, and it magically gets given to you, right? And it's a really useful part of actually being able to test things out properly and mock things out. But unfortunately, a lot of the cloud technologies and the basic things like Express and UWS, you need to build these things from scratch. We also have this really weird trend, in my opinion, which is obviously subjective to myself, which is where people are starting to put backend code directly inside of their frontend code and creating this SSR weird thing where you're rendering a div and right next to it, you're doing a database call. And finally, there's this sample thing that's simple, which is, again, if you're going to be looking at starting with an actual technology, how easy is it for you to get off the ground? So you're pretty much saying, okay, I'm looking at the documentation. I want to get something live. How much do I actually have to learn? Do I have to go through pages and pages of documentation? Do I have to create loads of actual files, bootstrap files, boilerplate code? And so you'd notice that the less functionality things have, the simpler things usually get. So it's a trade-off that we have to make. So this part I'm kind of hoping would be a bit more interactive, which would be, if you heard any of these statements, or if you even thought about any of them, just feel free to raise your hand or make a noise, no pressure. AWS is way too expensive. I wish we could save money by running it on Cloudflare. Awesome. So AWS is extremely expensive because you have to pay for the actual bandwidth of your Lambda usage. And so because of that, the cost can really spiral depending on how you use it. Cloudflare, for example, is practically free when it comes to bandwidth. Why is that Docker job processor so underutilized? We just landed a huge new client. I just wish they weren't using Visual. Again, feel free to replace these things if you want to. We want to start offering our cloud product to on-premise or enterprise users. So I'd seen one hand up there from a conversation earlier. Why are we now doing our database queries directly from React code? Again, this is a pet peeve, trying to gauge it. Thank you. I needed some validation for that one. What is all this boilerplate code? I mean, in fairness, this is probably why I started with Vramework, using things like Nest.js. I mean, whoever thought of taking Angular and putting it in Node, in my opinion, yeah, I mean, it's great. It works really well, but it's a lot of code. Why is it so hard to deploy our WebSockets via serverless? Awesome. So just a raise of hand, how many people here use WebSockets? Okay, and so I'm assuming all of you are running, how many of you are running it via serverless? How many are you running it on serverless? So without running it with, running it on AWS Lambdas and so forth, or Cloudflare WebSockets? How many of you knew that you can run it on serverless? So yeah, so why is my function startup time so slow? I mean, this is pretty important because of the fact that slow startup time usually ends up meaning much bigger bills, and also lower latency usually makes clients a bit unhappier. And finally, and which is pretty important, I believe, is like, what about the Earth, right? So this is pretty important because there is a huge movement right now in terms of actually monitoring the environmental impact your code actually makes. There are lots of startups and regulations that are coming out around this. And normally this comes down to how many CPU cycles are you actually wasting? And they turn this into actual code that your company may actually have to pay fines on. So this is something we're going to have to start taking into account within our architecture decisions. So yeah, so the problem that I see across all of those things that they have in common is first off costs. So switching between different serverless providers, some of them can be really expensive, some of them can be really cheap. And then lock-in, and lock-in is definitely the biggest one. If someone decides early on in the project, I'm going to go with Lambda, you're pretty much going down that route. Your entire tech stack is going to be built around that. If you're going to be going down something like Express or UWS or anything that's offline, you can deploy these things via serverless, but you're going to end up having a lot of bloated code, and you're also going to end up having pretty much higher costs than you should. And so my solution to this is pretty much typed functions, aka Vramework. So what exactly is typed functions, and why would I suggest it? So the first one is it's purely modular. A function is usually the smallest amount of code that you can write, super easy to test. And because it's modular, it means you can use it across multiple different places if you want to, which is portable. The third one, and which is extremely important to me, is serverless design. So when you're writing your code, even if your code is running offline, or if you're running in a Docker, like or in a UWS or WS or any kind of WebSocket server, it would be really useful for you to design your code in a way that if it was to deploy on serverless, it can actually just run straight away. There's obviously downsides and upsides to this, which is why I mentioned speed. If you're running things locally, you obviously don't have to do all these weird network hops that you would inside of Lambda serverless, for example. But being able to design your code exactly the same way can essentially allow you to deploy it to both serverless and serverless deployment tactics, I guess, the same way. And finally, TypeScript, which is why I'm so happy to follow the previous talk, because a lot of it's built on this. TypeScript just makes everyone's lives much easier, and it gives you it allows you to sleep at night. So some of the key features that Vramework provides, the first one of it is protocol agnostic. So this is really important because of the fact that you could write a function. This function, maybe it's going to be called from a HTTP invoker, maybe it'll be called as a cron job, maybe it will be called via WebSockets. It doesn't really matter. At the end of the day, a function depends on what comes in and what goes out. Services and auth have to be built in because these are two things that are fundamentally really important to be able to make testing really easy and also just to maintain decent lifecycle approaches in your servers. HTTP scheduled tasks and WebSockets should all work, should be fully type safe. So I take a very similar approach to what we spoke about in the last talk. So what I do is I actually generate all the types directly from the database. You don't have to. And then those types get propagated all the way to your UI in the front end. If you decide to delete something inside of your database, like a column, your UI code will throw an error as well as everything else, depending on how you set up your project, obviously, whether it's mono or not. Runtime schema validation. So this is very similar to Zod, but it's also a lot more transparent. If you just define your actual TypeScript types, then it will automatically create the schema for you. And then when the function is called, it will validate that those types are valid. So this gives you runtime validation, as well as the compile time that you expect as well. And there's a bunch of other features which you get, which is like OpenAI. You can generate documentation. You can generate all these different types of type plugins. And we'll get into those if we have time later. So we're all developers. And I think what sells developers the most is looking at code and then hopefully understanding it on the first attempt. So this is pretty much the heart of what Vramework is. So the idea here is that you have a function. The function takes a type. This type is going to be a bunch of input, which is a TypeScript type. You have a second type, which is the output, which is what the function's meant to provide back. The function takes 3 parameters. You get given services, an object that allows you to interact with the state of the world. This could be an email service, a database service, the SNS service, like anything that the function, that you rely on as an external service. The data So this is probably one of the main and only things that Vramework took a very opinionated design on. And I would love to get feedback on this afterwards if anyone thinks it's a bad idea. If I'm calling a HTTP function and I have things inside of my parameters, I have things inside my query, and I have things inside my body, normally I don't care where things come out from, except when I'm generating documentation. So what that means is I don't have to say, get me the talk ID for my query, and then also happen to get me a talk ID for my body, and they might be different. This isn't a situation I would normally encounter. So what Vramework does is it squashes all of those together, validates it against the schema, and then says, is it true or not? And the third thing is a user session. So it's really important when you invoke a function that that function understands who is actually invoking this. Is it an anonymous user? And if it isn't, what is the context of that user? It's important if you're going to be doing things like a database, an audit log, for example, or many other reasons as well. The function body, this is just a really basic example. I'm going to say, under talks, I'm just going to add a vote. And if I already voted, it will throw an error called already voted. And then finally, it will just return a message saying, thank you for your feedback. So this is a function that hopefully would be pretty easy to understand its signatures and to understand the actual inputs and outputs that come out. When it comes to actually routing the function to a HTTP endpoint, what we would do is we'd call add route. We would provide the method, which is post or get or patch, etc., the route itself, the function we expect to invoke when this route is actually called, a bunch of permissions. So these permissions are ordered together. In this case, we'd say, is it a talk member or is it an admin user? If it is a talk member, is it both a talk member and is it not the presenter itself? So now we have the ability to actually say, this function won't be invoked until all of these things are met. And the API for these actual permission functions are literally the same as the ones that we've seen, except it returns a Boolean true or false instead of an actual message object or data output. We also provide documentation, extra documentation that we'd want if we want to actually generate open API docs. So we would define all the different types of errors that can potentially be run. We would define the different tags. Like these are all the different things that you would, metadata you'd augment your function with. The function already knows what your JSON input is like. It already knows what your output is like, so it can generate all of these things automatically for you. And finally, as I mentioned, we want to abstract away the difference between whether HTTP land and function land, right, or user land. And so what we do is all we do is we map the error that we defined with the actual status code and the message. If you want to throw the error and provide more detail, you can just pass it inside of the constructor, and it will pretty much pass that towards the client. So by doing this, we have now completely split out the design from the functions itself and HTTP. If you're going to be testing the function, you could test it the way you'd normally test the function, which is like, does it throw an error? You don't have to care about like the HTTP elements behind it. The same thing applies for cron jobs. The difference with a cron job is when you run a cron job, there is no user session. So we have a different type called sessionless. A sessionless function is pretty much the same as a session-based one. The difference is the user session may or may not exist. So that means if you're calling an API, for example, and that API says is an SSO, like your server rendering some things in the backend, or you're getting some details in the backend, you might want to say, okay, normally if no one's logged in, this is what I'm going to provide. If someone is logged in, I'm going to actually tweak it a little bit, amend it so the order is different based on the user preferences. You would use something like an API function sessionless because being logged in or not doesn't matter, but it does provide extra context. However, in the case of the cron job here, you'd notice that we just don't take an input and we don't take an output, which is why they're both void. We give them all the services. And in this example here, we're basically just spamming everyone, right? We're saying, okay, get all the user emails, send them all a newsletter, and do that once a minute. So what is services? Because I mentioned this quite a bit, and like services, again, in dependency injection frameworks can be quite wholesome, or like there's a lot to it in terms of decorators and so forth. So servers in Vramework constitute as two different things. The first thing that you do is that you create a singleton service. So that's equivalent to what we've seen in the first talk, which is when you cold start a Lambda function, those are the services that run for the duration of the entire lifetime until it gets cleaned up. If you're starting an Express server, those are the services that are created when the Express server first starts up. And then it will only be killed when the actual server shuts down again. So these are lifelong ones. Vramework has a few of them that are completely optional that can be consumed by the library. For example, here we have the HTTP session service. And this here is responsible for actually saying, if a HTTP call is made, I want to be able to extract the user session to pass to functions. So you can see here that it says, okay, what is the cookie that we expect to have, and then decode it, for example, using JWT. And there's also other APIs in here that I haven't mentioned, such as getting the API key directly from the headers, or like being able to get an API key in the query parameters. And then all we do is we literally just return the actual services themselves. So these services are just normal classes. There's nothing special about it. You can import it. It could be an AWS class that you directly create straight away, right? The second part that we have is the session services. So the session services are services that are created purely for the lifetime of that one function. So that means the service is or can be aware of the HTTP call, or it could be aware of the actual session if it needs to be. And a couple of examples of this would be, for example, a temporary file storage. If you want to create files and you expect these files to be deleted after the functions run, that would do it. You can also do a different one, for example, that says, because we want to hide away the HTTP concepts completely from the functions, if the organization ID is inside of the header of your HTTP, you can create a basic service, and then you'd say, okay, have an API call that gets the organization ID for you. It's worth mentioning you can override it and access the HTTP call directly from the functions if you want, but it isn't recommended as a design decision. So let's just take a quick break away from code and just explain how this works internally. So everything that we mentioned right now is your type logic. None of this is, like all of this is purely based on TypeScript types, the ones that you've just seen right now. API function, the create services, the create session services, and the wiring. So once you write that, you can run the Vramework CLI. The Vramework CLI goes in, inspects all of the actual codes that you have based on top of the TypeScript compiler. So it's an augmented, or it's an extra program that runs on the AST, the TypeScript AST, and it pulls out all the things it cares about. So it'll pull out all the HTTP routes, the schedules, and so forth, generate your OpenAPI documentation, and most importantly as well, it will also figure out all your inputs and generate JSON schemas for them. So just by having pure TypeScript functions, types, it will generate the schemas that you can validate during runtime. We have a small library called Vramework Core. Vramework Core basically attaches all of these things together. So if you're going to say, I want to run a HTTP function, it's going to be like, okay, I'm going to check that it's authenticated, that the permissions are there. There's a very minimal amount of code. The whole library can be about 20 kilobytes. And it has no concept of what an actual HTTP server is, or like a transport layer. All it does is it bridges across the HTTP servers that you have, or the HTTP concepts that you have in all these different things, and then essentially allows you to call into them. So for example, if you have an AWS thing, you just call directly into the call and be like, okay, I want to run this HTTP call. And so based on this, you can now take the code that you have, generate these things, and run exactly the same code you have immediately on almost any one of these platforms. And these are the ones that I've currently created, but because I don't really want to create them for all the frameworks out there, because I don't have that much time. The CLI itself is really simple, like in terms of the configuration. There's more things that can go in here, but you just tell it, this is my TypeScript configuration file. These are my root directories that I want you to inspect and pull out all these roots and cron jobs from. And this is the output directory to just generate my types. Now, it's worth mentioning that we don't generate code, right? We're not generating SDKs. We're generating types, and then these types are consumed by a very small class. So some libraries would actually generate like hundreds of different functions and fetch parameters. We just have one function. That function gives you all the types that you need, but during compile, none of those actually will end up in your bundle. So your bundle size will remain tiny, but you'll get exactly the same functionality. So let's talk about how you actually can deploy this, right? Because we don't want to do this and then not be able to deploy it easily. So this is an excerpt of how we deploy it by Express. So the first thing that we do is we import the bootstrap. So the bootstrap is Vramework's way of just saying, these are the few files that we generated that you need to run a HTTP call out of the box. So this will basically just import all the roots that it found, and it will import all the schemas that it generated. All of those things, again, are run during compile time. None of this is done via the actual runtime. So once it's built and your Docker file is there, that's it. You're not generating any build tool, you're not running build tools or anything like that. So the first thing you do is you get your configuration, which is a configuration you want to initialize your services with. You create your singleton services. In the case of Express, Express doesn't have an actual cron job runner. So you would say, okay, use Vramework's task scheduler. This is literally just a thin wrapper around NPM's most popular cron job library. And it allows you to just say, okay, start all the jobs, cron jobs I defined, or you could start them by name, you could start and stop them. It just gives you that simple functionality to deal with cron jobs. And then when it comes to running an Express app, you'd say create the app. You do have to add the middleware, because again, Vramework doesn't do any of that stuff. It doesn't care about how you want to parse things. AWS already parses the JSON when it gives it to you. Express doesn't, for example. But what you essentially want is just the Vramework middleware plugin. And what this will say is I'm going to now take all the routes that have been defined in Vramework Bootstrap, and I'm going to use them. And so now I can pretty much just run this, and it will pick up all the routes that I have defined in my system. Now, let's say we want to run exactly the same things now in AWS. You would say, again, import the Vramework Bootstrap. Obviously, in AWS, size matters, which means that what you care about, you might actually want to care about importing individual functions. If you import individual functions, ESM will tree shape, your bundle size will end up being much smaller. But for this example, we just say import the Bootstrap. We do the cold start, as was mentioned earlier. So this basically says the first time we run it, initialize it. After that's initialized, so we don't have to do it again. And then this is all the code we need to tell AWS, hey, when something actually happens, route this now to Vramework. The same thing when it comes to running a cron job. You say, okay, create a cold start, and then this cron job will now run. And then these things are wired to AWS the same way you would wire any other API, AWS function. These are essentially AWS functions, as far as we're aware. And they are, not as far as they are AWS functions. So who wants to see a quick demo of how it runs? Okay, I see a few hands. So let's see how this works. Right, so the first thing I'm going to do here is I'm just going to show you what the actual CLI output is. So I'm going to run npx Vramework CLI. So what you'll see here is it pretty much just ran through all of our code and it generated all these things that we actually care about. So what this means is we'll have all these different, again, all of these are just types. So you'll notice tons of them. And yeah, and then also importing the actual functions that have the things that we care about. And we also have root metadata, which contain things about knowing what schema to use and so forth. Okay, but we don't want to actually look at that. What we do want to look at instead is going to be how can we actually integrate this into the plugins and into the front-end code a bit. So how many of you use Next.js in your job? Okay, that's a good enough number for me to demo. So here I have a Next.js app. Inside of the Next.js app, I'm using Next.js 15. Please don't hate me, it's just the way the world's going. And what you'll notice here is a few things. So the first thing is we have our to-do page. So again, normally people would, in here, they would say, okay, this is my database. I'm going to do my database query and so forth. Instead here, we're just going to be like, pull to-dos. Now, it's worth mentioning, next, I'm not running a separate HTTP server. I'm not doing any of this. I'm literally just saying Next.js, give me your HTTP, your concept of what a HTTP server is, the way you deal with cookies and everything. I'm just wrapping that around so I can interact with it better. And again, what's most important is the fact that everything has to be fully typed. So these are all the different routes. If the route doesn't exist, well, I kind of have a problem. And that also means that automatically, I know what my to-do outputs are, and it's going to be get to-do outputs. And those are, again, generated automatically from my function definition file. Now, you could do the same thing across the board with everything. So you notice here, it's going to be like, okay, well, I have a post. So if I say I want to have a post, it'd be like, well, a post kind of requires something. And so we have compile time TypeScript help. And at the same time, we also have help with the compile time, with the runtime as well. So if I was to do this, which I can't run because it will fail, it will then tell me, by the way, you're passing the wrong parameters. And I'll show you that in a second. And so, yeah, so this is how you would do it inside of the actual Next.js. So I'm only supporting the latest libraries. Before I was supporting multiple versions, but it's just too much work. And I don't think it's really worth it unless there's a desire for it. If you look at the same thing with Fetch, So it does the same thing, which is exactly the same autocomplete. Again, it's worth mentioning that Vramework, like the libraries themselves, are really quite small. I mean, you'll notice here, all they are just helper functions around exactly the same function, which just give you TypeScript definition benefits. And then the actual function itself is also just a couple of, it just wraps the fetch API itself and makes it intuitive to use. If you look at the actual functions that we have, you'll notice that here we just have the source functions, like I mentioned. And so when I do this, I actually expect that, so what I do is I derive all of my actual types from my database. So I use Kleisli. Who here uses Kleisli? Who here uses Postgres? Okay, if people are using Postgres and you like TypeScript, Kleisli might be your new best friend, as long as you're okay with using like simple query builders. It's fully typed, so it knows what all your types in the database are, and it will pretty much allow you to pick all, like it will know what fields you can select. It gives you full validation over everything that you do. And from this, we can say, okay, this is the to-dos that I actually get, and this is the kind of outputs that I expect to come and the input that I expect. And pretty much, so if I don't know, yeah, so that's pretty much the idea. I don't really want to start typing code because I know that I'm going to start making mistakes and then, but you'll notice that this is pretty much how we do all of the different stuff here. And you'll note, and it's exactly how I explained with the scheduler and so forth. And then if you're running the workspace starter, which is what I have. So if you are interested in this, I provide examples of all the different types of deployments we currently provide, including serverless and server-based ones. You'll notice like how you can actually set them up. Normally, again, it's a very small amount of work. And the Next.js aspects and so forth. And I'm using a Yarn workspace, which means that all the types across all your different things are pulled in together. So different teams have different opinions on how you can do things, but this is pretty much how it goes. So I'm happy to answer more questions or delve into the demo later. I'm just aware of finishing this up. So limitations and caveats. The first limitation is Framework is a function repository, not a server. So what this means is almost every single framework that comes out, whether it's like even, I believe, gRPC, it's like you provide the actual server itself, like that it hooks into. So I don't know how that would run, and I'd love to get your input on that if it runs from a serverless concept. But what Vramework does is it literally just pulls all your stuff and it goes like, okay, these are my functions for HTTP ones. These are my cron jobs. These are my WebSocket connections. And it just gets them all to be called effectively. We currently just support JSON and primitive types. I did add support to XML and different things according to different companies I worked on. But I mean, for this release, which is still 0.x, which is now using this TypeScript inspector quite a bit, yeah, these are the two main things that we're looking at. The roadmap that I'm looking at, first off, is I want to validate the problem space. I know that this problem space is something I face, and it's something I face in all of my clients that I work with. However, getting another framework, as I was told this morning, to not just be another framework is quite a hard sell, and I need to first compare myself to everything out there, make sure that I can actually make developers' lives easier. And then also, just make sure that, just see whether people want to use this, right? Because if not, I'll continue using it, but I won't put in the investment to turn into a full open source project. It takes a lot of time. The second thing is to build a community, which is essentially not just users, but hopefully contributors, people who are willing to raise bugs, who are willing to use it out. AI tooling. So AI tooling apparently is a new buzzword for 2025. They say that what will win the backend framework wars will be whether or not an AI can do it for you. The benefit of using Framework in this context is the fact that we have everything typed. We know exactly, we have a function. And by combining those two things, it becomes really easy for us to tell an AI, okay, these are my services, these are their interfaces, this is what I want this function to do it for me. As opposed to having to tell it, please generate 5 classes and link them together. And finally, a smarter inspector, because dealing with TypeScript compiler is so much fun. And microservices. So microservices is just the ability to actually pull multiple functions together. And then because it's modular, ideally you can say, okay, all these functions have got to do with billing. I'm actually going to publish this now as its own little package. If people want to add this into their own project, as long as they know exactly the services that billing depends on, whether you abstract it away, so you can actually put in different ones, or whether you say this is a Stripe billing library, you can now just insert functions, and you can start having this world where you actually share backend function code a little bit. Obviously, please make sure you read the code first and run your tests and security analysis. So, in summary, Vramework is typed function plus minimal overhead. And we do that by leveraging the TypeScript compiler to pretty much remove all the different levels of boilerplates that we normally are aware of. It handles HTTP, cron, auth, and more. Queues are a huge part that I think is really important as well. Most job facet, so that's on the roadmap. It generates creates loads of generated TypeScript helpers. So what this means is, again, WebSockets, fetch, all these different things, and you can deploy it pretty much anywhere. Like, as long as you have a WebSocket server, or you have a concept of a timer, or you have the concept of a HTTP, you can pretty much bridge the gap. The caveat of that, of course, is it doesn't allow you to upload files. It doesn't allow you to do binary streams. But normally, you don't have to do that. And if you do, those are routes that you can usually just say, OK, I'm willing to put in the effort to make this separate for Express, but 90% of my API should be ubiquitous and usable. So this is the end. It's my first talk after working on this nonstop for about 5 months or 6 months. If you like it, I would really appreciate a star. The feedback is literally a Google form, and so I can get some feedback on where you think I may or may not want to concentrate on. I'm open for questions, and I also am willing to show people how a serverless design works, but I'm not so sure on time. So we'll see how questions go first. OK?
Yeah, I'm kind of thinking of a use case in case of a basically legacy system where we know we have to still develop something, but it's clear it's going to go to AWS or Azure or something, but currently it still has to run on a backend system. So my question would be how much would one have to get into to write one of those basically services that is abstracted away? So how much would I have to write for that? Might it actually be worse to write something that's just for an old service, just so later we don't have to change everything and can just switch to a different system instead? Might that be a use case?
Yeah. So migration paths from current code bases is something that I put a lot of consideration into. And so I would like to say that it's barely an inconvenience. But I mean, obviously, so the main aspect behind it is when you generate your services, like in that create services function, you can hydrate from services that already exist. So based on that is you can say, OK, these are the services that you have, but I'm going to be passed these services in from the older code base and legacy code base. So as long as those services are something you can pass through and they're class-based, that should be fine. If not, I mean, there will be a deal of refactor. But again, the good thing about it is if you can do that, you can pretty much plug it in as a middleware into Express and Fastify. So you can easily say it's going to be version 3, and that will happen. But in terms of getting the two code bases to interact, I would say that's the way you can get both the new code base and the old code base to collaborate together.
OK.
Is there any other questions? OK.
So you gave a good Next.js example question. So if I understood correctly, the example, it doesn't actually do a request to your server. It just loads the data, right? So
that is correct.
Is there like an advantage of using this route ideas in Next.js server, or do you think it's just like it's an idea for Vramework to be used with Next.js?
So I have very mixed feelings about that because embedding backend code and frontend code for me, again, is something I don't really like. But again, it's the direction that some servers are taking, like TanStack Start as well. So the idea behind it itself is what I'm trying to do is obfuscate. I'm trying to abstract away how Next.js recommends you do things, but instead of doing it via instead of just saying, OK, I'm going to go on a completely different route where I'm going to actually make a separate HTTPI call, I'll have the best of both worlds. Like you have your database and everything loaded within the actual node, like the Next.js process itself. But you hide away Like, so when you do your tests, you can test all of those routes using normal end-to-end testing. So there's a lot of benefits that you get from that, but you don't lose whatever the benefits are that Next.js claims it gives you. So I'm not very versed in the benefits of Next.js. I was just trying to make my life easier. And this way, it supports both mechanisms. Does that answer your question okay? Yeah, perfect. Any other questions?
Hi, very interesting project. Thank you for the talk. And maybe just to clarify a thing which I might not have understand correctly, like you showed two deployment models, like one deployment model with Express and one deployment model with AWS.
Mm-hmm.
Now, when I deployed with Express, I guess I will get like a JavaScript binary, a bundle, which I then can start on the server. Is that correct?
No, so if you use it with Express, it's literally going to import all the functions that you care about, and but it doesn't generate a bundle for you. It will import the functions directly.
Okay, and then I'm responsible to just run this Express.js app somewhere.
Exactly. So if you just run the Express server with the middleware and you import, so what Bootstrap does is it says I'm going to load all of the files with HTTP routes, and then it registers it in a global state. And then when the Express middleware basically just proxies these things to it.
And then I can deploy this to like Heroku or something.
You can pretty much deploy it anywhere you want.
And when I go with the AWS solution, how would that deployment look like? Would it be like executed as a Lambda, the function instead? Or how?
Yeah. So with AWS, the way it would work is it would generate an actual bundle. So I use not Webpack, but the newer Fight, I think, or I'm not sure what the newer version of ESBuild, sorry. So I use ESBuild to pull all the stuff together because it does really good tree shaking. And then you use that bundle and deploy it. Because I use serverless to deploy things, and that's the approach that I do. But essentially, it's exactly the same concept. So it's aware of where all your code, your functions are, and it bundles them together. If you happen to use a different way to deploy AWS code that isn't bundled, it should theoretically work, but I haven't tried it out.
But in the AWS example, who manages the routing then? Like when a request comes?
AWS does. Oh, in my case, it would be serverless. So if you just look really briefly at the actual serverless code here, you would see that serverless basically says, So here, what I'm doing is I'm basically routing everything to that one function. However, you can pretty much say, I want to route each thing to each function, and then you can create a bundle for each individual function, which means each individual function would be much smaller. So it really comes down to convenience versus practicality.
Okay. Yeah, I think I got it. Thanks.
Awesome. Thank you. Any more questions? Okay, awesome. So we're kind of running low on time, so unfortunately, I can't show you the WebSocket code, but if anyone wants to see it, you could just ask me after the talk. And that's it. Thank you very much.